3.5, we get to bring out something that we haven't used the whole chapter, which is your calculators. Why? Because we actually do that kind of math. The math that we've been doing has been logical, has been reasons, has been proofs, has been how to prove triangles congruent to each other. So in this section, what we're going to now do is we're going to start solving problems that deal with these two ideas, isosceles triangles and equilateral triangles. The first thing that you need to know, if some triangle has two sides that are the same, then that must mean that two angles are also the same. The angles are very specific. If this side is the same as this side, then the angle across from it is also the same. If this side is the same as this side, then the angle across from it is the same as each other. You can just draw. Oh, it did not work. Let me try that again. You can just draw an arrow. The two angles that are across from the sides that are congruent are also going to be congruent. Those are called the base angles, even if the triangle's on its side. And these two sides are the same, then the base angles are now over here, because they're the ones across from the two sides that are the same. If two base angles are the same, then the two sides opposite them are also going to be the same. We'll do a variety of different problems that will ask you to find the base angles or find the vertex angle, which is the angle that in between the two sides that are congruent. One other thing that we're going to do with a isosceles triangle is going to deal with Theorem 22. Doesn't have a name to it. It's just a number in your textbook. This is in your textbook, so you don't need to write it down. But it says, if a line bisects the vertex angle of an isosceles triangle, then the line is also perpendicular bisector of the base. And there's a way to prove that. It's a real simple proof. So think about this. If this is isosceles and this line goes through and it bisects that angle, this angle is the same in both. Then I could think of, I have a side, I have an angle that matches, and CD is the same as CD, so therefore these two triangles must be the same. And if those triangles are the same, then their corresponding parts must be the same, including this angle and this angle. And if those angles are the same, then they must add to 180. They must both be 90 degrees and 90 degrees. And these parts must be the same. So that would make this a perpendicular bisector. It is something that's provable. That's why it's called a theorem. The difference between a theorem and a postulate is that theorems can be proven, whereas postulates are facts. So we're going to use this idea in a later problem you'll see. The last concept that we're going to do are dealing with equilateral triangles. And in equilateral triangles, if three sides are the same, then three angles are the same. And vice versa. If the three angles are the same, then the three sides are the same. That's what equilateral means. Equilateral means equal sides. That's what equiangular means. Equal angles. So dealing with that, if you also want to say that if it's equiangular, you know what each angle needs to be, which is 60 degrees, 60 degrees, and 60 degrees. Which brings us to our examples. I have three chosen for you. Numbers 7, 9, and 15. These won't take us very long. If you want to turn to whichever page it is, let me see, 3.5, page 161. We're going to number 7. The equilateral triangle and the isosceles triangle shown here share a common side. What is the measure of angle ABC? A, then B, then C. They're asking for the big angle. You're going to have to use the two facts above to figure this out. So the first thing I would say to you is, we know this base angle is 66. It's across from the isosceles triangle, so I know what this angle has to be right here. If you know what that angle is, say its measurement out loud. I agree. And then what I can do is I can find out the vertex angle by adding these up and subtracting from 180. So that's where my calculator comes into handy. 180 minus 66 minus 66. I'm going to write that down. So I know that the vertex angle has to be 48 degrees right here. It's half of that, not half. We don't know if it's exactly half or not yet, but I know that's 48 degrees. That's part of the angle. And then I see that these three sides are the same and it's equilateral. If it's equilateral, do you know how many degrees each angle is? So to find the measure of angle ABC, I have to take this shorter angle and add the angle over here, this bigger angle, to get the whole angle, otherwise known as the angle addition postulate. I have to use the angle addition postulate to figure out the bigger angle. So I'm going to take that 48 degrees we found. I'm going to add 60 degrees to it to figure out what the measure of angle ABC is. The measure of angle ABC is 108 degrees. Do you agree with me? Simple. You may not even need a calculator for that for some of you. Number 9. One of the reasons why I chose 9B was because the 42 is in a weird spot. It almost looks like it's in the exact middle of that left triangle. So this 42, in case you were wondering, is not closer to this. It's actually closer to this angle than all of them. So what that means is that angle L is 42 degrees. We need to start with that. Now angle X is this angle here. And because there's an arc, it tells you this is also angle X right there. Has to be. You can do this in any which way you want to. But for me, since I have an isosceles triangle, and I have this side is the same as this side, I know if that's 42, then I know what angle M is. That's going to help me. That also has to be 42. Now, if I said this was X and this is X, and I think about this big triangle, let me use a highlighter here. I'm going to use the green highlighter. How many degrees do they add up inside a triangle? I can do that. I can just use that fact that 42 plus 42 plus the x should add up to 180 degrees. I can do it that way. That's just one way to do it. Or, if you want, you can use Theorem 22. Theorem 22 says if these two angles are the same, if this is on an angle bisector, then you know it's on the perpendicular bisector, and you can just put a 90-degree angle symbol right there because it's going to be on the perpendicular bisector. It's up to you. I'm going to do it this way just because that's what came first to my brain. X plus x is 2x. 42 and 42 is 84. I'm going to subtract 180 minus 84 on my calculator and get 96. Divide by 2. X is 48. Which would make sense because 48 and 42 make 90, and that's also 90. It works. 48 degrees. Two different ways to do it. Last example. Number 15. It's an isosceles triangle. Find each value. So the value we have to find, if L is 58, I'll put a 58 in the picture. It makes it so much easier when you add the information in the picture. Then the measure of angle LKJ. LKJ. Anytime they give you three letters, they're telling you its full name. They're telling you the big angle. L, then K, then J. Because you can't just say angle K. Angle K would, how do you know which one it is? There's three different angles there. Got to use all three, the full name. Got to be proper. Well, if that's 58 and it's isosceles, I know what angle J is. Angle J has to be 58. Two sides the same, two angles the same. And so if I want to know what the top of this is and I have a triangle, I can figure it out by adding 58 and 58. That's 116. And that's what those two bottom ones make, so I can subtract that from 180 to figure out what's remaining. Do I have to cut that into two pieces? No. My answer for 15 is 64 degrees. In the other ones around it, you may have to divide it by 2. It just depends on how it's given to you. We're going to stop your notes right there.